Good morning, everyone. How are we?
Morning,
Fine,
Wakanda.
thank you.
Okay, so welcome back after a week break, which was unfortunate, and I apologize for that. I don't know how it happened. I slept on my neck. It was a pain, but I have recovered very well. So we go back from where we stopped. And today, last time we looked at equations, non-linear. So we will look at its application in business world. Most of the applications we have been looking at is more of economics application. So when it comes to non-linear, of course, the application we have seen one whereby we have to solve demand and supply. That is one application. Now let's look at the business side of this non-linear, to be more specific, quadratic equations uh, and profit. So first of all, it's important we build our intuition about this topic before we just go on to solve some examples. I think one of your assignment has to do with this topic, and I have sent the assignment to you people. It will form part of your grades, and then I just send the deadline. It will be Tuesday. You can contact Mr. Ahmad. I put the number there. But before you go there, you make sure you call him because it's not like he's always at the campus. So you call him first. So basically, we will. I don't think I put extra 1 hour today, but I don't think we will not need it. So after this class, we will have one more class. The goal is to use it to introduce calculus, that is derivatives and differentiation. But let's see what we will cover first. So at the end of the class, then we can have a discussion around it. So whether we will use it for revision or we will use it to do basic calculus, something like that. All right. So we have revenue, cost, and profit. I'm not going to do any definition. As a business student or even economics or social science student, these are things which everyone knows. You know what is revenue, you know what is cost, and you know what is profit. So we will start it with what? One with a profit function. How do we drive profit function given some information about cost or demand and revenue? So we know that profit is just the difference between the income or the total revenue uh, that's the seller received and the expenses, the seller incurred during production process. So one symbol that we normally use for profit function is more like a pie. So this is the symbol we will be using throughout this. So whenever you see this, it's talking about the profit or the profit function. So the next thing that we need to know is like, how do we calculate this profit? Basically, profit as a business people or social science, everyone's supposed to know this. And on our is the total revenue, which we represent in this course as TR, then minus the total cost. So if you want to find a profit function, obviously you need to know your total revenue function. You need to know your total cost function as well. So because we need to know our total revenue and total cost function, we will spend some time trying to calculate total revenue and total cost. So the second part, now we define what is the profit function. Obviously, this is a summary of profit function, but this is knowing the formula is key, and knowing its components, which are total revenue and total cost, is also key. So let's look at total revenue. And as I say, total revenue is the total income received by the seller or producers for selling a commodity or a service or rendering a service. So we have this, and the formula is that the price times the price of the goods and services the seller is selling multiplied by the quantity sold. So we have this. So this is our typical total revenue function. And if you, this topic is what quadratic, non-linear, to be more specific, it's quadratic. So at the end of the day, the total revenue function we will have, it will be quadratic. So this price will be given to you most of the time. So all what you need to do is to multiply it by the quantity. So within this price, you have quantity there. You multiply it by another quantity, it will turn into a quadratic equation or function. So first, let's even take a typical example. The reason why I didn't give you due date for your assignment, because I didn't cover this and it was in the assignment. So I felt like, you know, I should cover it, then give you extra 1 or 2 days, and then you can submit it. So let's look at a practical example whereby we will be asked to drive a total revenue function, and they will ask us to find the maximum value of TR and where the total revenue is also 0. So let's take an example. This is everything is in the book that or the handout I gave to you. So let's say that first, given demand function will be given to you. That is P equals to, so the price is given to us, but this price, it represents the demand function. Is what? 100 minus 2Q. We have that. So this is given to us. And now the task here is what? You know, is to find the, you know, you can say drive revenue function, or you can say that express, most often this is expressed total revenue as a function. So this statement should be familiar to you by now. So what they are saying that in this question is to drive total revenue function, and the inputs there should be quantity as a function of Q, which is quantity. And also it will ask us to sketch the total revenue function that we have in A. And let's say we have C is asking us, so what is the value, what is the value of Q, sorry, this should be if total revenue is equals to 0 or is 0, then the D, the last one, what is the maximum value of total revenue. So these are the questions. Remember what we are doing, we are systematically studying the profit function. We know that to understand the total revenue function, we need to understand, to understand the profit function, we need to have understanding of total revenue function. We need to have understanding of total cost function. So we start the journey with total revenue function. So this question is related to total revenue. We are given a demand curve, which is the same as price equals to 100 minus 2Q. So we have A up to D question related to this total revenue function. So let's look at this, the solution. First of all, what the question is asking us is we should drive solution. We should drive the total revenue function solution. So A is like asking us to find what? TR, that is total revenue. And we know that TR is what? Is the price times quantity. We know this. So equivalently, we can say that this total revenue equals to, we know our price. If you go back, our price is what is given to us is this. It's P equals to, that is our demand curve. The price is our demand curve, 100 minus 2Q. This is given to us in the question. So we have this already. So it's like the price, which is 100 minus 2Q multiplied by the quantity, which is this. So at the end of the day, we'll have a total revenue function like this. So at 100 times Q, that is 100Q, minus 2Q times Q, that will give us 2Q square. So you realize that this total revenue function is a quadratic equation. Of course, the constant term there is 0, is missing. Sometimes quadratic equation, the constant term can be missing. The linear, even the linear component could be missing. But what could not be missing is this one. So the coefficient to here cannot be 0. So here could be missing, or constant also could be missing. But the quadratic component can be missing. That is, the coefficient can be equals to 0. Should be greater than or less than 0. So now we have this total revenue function. This is what it is asking us to do in question A, express TR as a function of this. So this is done. Now they say sketch the total revenue function. So we talked about how we sketched B, so we have a total revenue function like this, 100. Yes. Yeah.
Can you go back to the A part? Can you go back to the A part? I'm just coming in.
We cannot drive the whole class back. I'm sorry.
Yeah, I just want to take a snap of it. I know that you.
You can be quick. You can take it on. What you can do, you wait on once I download it. So this is the price we pay for coming late. All right.
Okay. You can go.
All right. So we have total revenue is equals to 100 minus. This is even the handout I shared with you. You have this there as well. I'm just following it. So we have this, and here with last class also this can equivalently we can express it as this because we can just rearrange it so that the quadratic term can come first. It doesn't change any thing. So this is the same thing. So we talked about how do we graft quadratic equation. The first thing you should notice is like you have to know the sign, the coefficient here. Is it positive or negative? And if we say that if it's positive or if it's negative, the graph will look like this. If here is negative, the graph will look like this. It will be inverted U curve. But if the sign here is positive, then it will be like this. So this is maximum, and this is minimum. So you can even know the shape of your quadratic graph even before you even start drawing it. So the first thing that you should look for is what is the sign of the coefficient that is attached to the quadratic component of to the quadratic component of the equation, which is this one. That is Q2. This is a quadratic 2. This is a linear component. So the constant component is not here, it's 0. So you looked at this, the sign is negative, then it will tell you that this graph, it will shape like this, that it will have a maximum point, not minimum point. This is the first thing that you should look for when you are graphing quadratic equation. And the second thing that you should look for is what? Who wants to volunteer? We talked about this. Who wants to volunteer? The second thing that you should look when you are graphing quadratic equations. What is the second thing that you should look for?
The y-intercept.
The y-intercept. So the constant term. You ask yourself, what is the constant term? The same as the y-intercept, as he said. Thank you very much. So here, what is the y-intercept here?
0.
It's 0, because normally quadratic, there is no, if I told there is +6 here, that will be the component, the constant component of the total revenue, that will be your y-intercept. So we know that the y-intercept is 0. Because there is no component, constant term. If constant term is there and is 4, then the y-intercept will be that 4. If the constant term is there, and that constant term is -3, then the y-intercept will be -3. So we have all this. The third one is to find the solution to the equation. So finding solution to the equation, that is, you use the quadratic formula to solve the value of Q. So these are the 3 information that you need to solve or to graph quadratic equation. So we know this is total, this will be total revenue. Obviously, this will be quantity. So what we need to do is, first, we know that the graph will start here. If the constant is 0 in total revenue, the graph will always start here, because we know that the shape will be like this. So we know that it will be something that will mark like this. So it will be something like this. So what we need to know here, the important point, we know that this is the y-intercept that is 0. We need to find this. So this is a point, these 2 points. Here total revenue is what? Is 0. Here also total revenue, in fact, it's here. It's also 0. So we want to find these 2 points, the quantity. We know that here total revenue is 0. We also know here total revenue is 0. So at what quantity total revenue is equals to 0? This is one of the questions. If we go back, what is the value of Q if total revenue is 0? So we want to know the value of Q, that is quantity, if total revenue equals to 0. So how do we find that? Here we know the first one. We know that quantity, when quantity is 0, total revenue is 0. So that is why we have y-intercept here. So here is what is left. And to find these two areas, what you do, you solve this quadratic equation using the quadratic formula. You can use the how to call it, also the factorization. But sometimes factorization doesn't work. So the formula always works. I don't restrict, so it's up to you. But it's important you know how to use both of them. So formula is something that you must know. You must know the formula. Factorization, sometimes it fails. So the other area that is important for us to know too is the maximum profit, the maximum revenue, the right revenue. So here, this will be our maximum total revenue. We need to know this area also, is important. So we also need to know that the quantity that maximizes the total revenue. So here is the maximum point. So now what we need to do, we need to solve this total revenue, which is a quadratic equation. So what we do, we go on and solve it. So we have this equation here. We will go back to the graph to plug the numbers. So if you say total revenue equals to -2 Q square plus 100. So you don't even need, sometimes you don't even need the formula. You understand? You can just directly, when the constant is not there, it becomes easier to solve quadratic equation. So what you can do here, you can either factorize it or use the formula. So you have Q here, and we have it here as well. So what you can do, remember, what we need to do, we are finding the quantity where total revenue is equals to 0. Remember, so we sketch the graph, but we'll come back to it and plug some numbers. But now we are looking at C. What is the value of Q? What is the value of Q if total revenue is equals to 0? So what we are doing here is the C component, or the C question. So there are many ways you can solve this. Some of the ways even myself I don't know. But the most important thing, we will arrive at the same answer. So you can factorize this. So they said that we want to know the quantity that will make the total revenue equals to 0. So what you will do, you say total revenue equals to 0. So we equate this minus 2 Q raised to the power of 2 plus 100 Q equals to 0. So we factorize this. So what we can have here, we can have 2 Q, we have Q here, plus, let's say, 50, or this should be minus, so that this will change, equals to 0. So at the end of the day, what we will have, it will be 2Q minus 2Q equals to 0. And then we have this here, Q minus 50 equals to 0. Oh, so at the end of the day, we divide both by minus 2 minus 2. So Q will be what? 0. So when Q equals to 0, total revenue also equals to 0. So when Q also equals to 50, this will come here, it will be 50. So these are the 2 points whereby total revenue is equals to 0. I just factorize this, but you can use quadratic formula also to solve this, and you will get the same answer. We can try that as well. So we looked at it. First they are asking you find the quantity, the level of quantity where total revenue is equals to 0. So you remove this and replace it with 0, and you try to find that quantity. So when we did that, the quantity is what is, we can call this Q1, we can call this Q2. So when quantity is 0, like here, when this quantity is 0 here, total revenue also is 0. So we know this already because we have it here. So the next one is we have to, when it's come to quadratic, you must have 2 points whereby total revenue is equals to 0. So the first one is that when quantity is 0, total revenue is 0. So when quantity is 50, total revenue also is 0. So this is the C part of our question. We answered that one. So this is in progress. This is answered. So what is the value of quantity if total revenue equals to 0? In another word, it's asking you what value of quantity, what level of quantity will make total revenue 0? And that quantity level is what? 0 and 50, which is this one. So some people, if this is a problem for you to factorize it, you can use your quadratic formula. So we still with C using the quadratic formula. If you can remember the quadratic formula, this is what we have. And this is the quantity. Now input equals to minus B plus or minus
Square root.
B raised to the power of 2 minus in bracket 4 times A times C, not so, all over 2A.
Yeah.
So what you need to know what is your A, what is your B, what is your C. And here our A and our total revenue function is what? Minus 2Q raised to the power of 2 plus 100. I'm not going to solve this. I'm just giving you work a way out. So A equals to what? That is the coefficient attached to the quadratic term. So A is minus 2, B is, this is Q, B is what? 100. And C is 0, because there is no constant in this equation. So C is 0. So all what you need to do is to substitute here and find the quantity. So when you do that, you will have something like that. B is what? Minus 100 plus or minus. B square is like, we take 100, we square it, minus 4 times A is minus 2, times C is 0. So this expression will become 0. So we only focus on this, all over 2 times A, and A is what? Minus 2.
Minus 2.
So once you go on, you will solve this. So at the end of the day, what you will have, quantity 1 will be 0, and quantity 2 will be 50. We have this. So we go on and solve this. So I'm not going further. We have done this. So you will have this. So when quantity is 50, total revenue is 0. When quantity is 0, total revenue is 0. This is the C part. So the D part is asking us what is the maximum value of total revenue. So we want to know what's the highest, what is the highest level of profit we could achieve with this total revenue function. So they are asking us this question, the maximum profit, the maximum total revenue rather. So here, to find it is very, very simple. First, what you need to do, we need to find the quantity. So they are asking us at what, we have to find the maximum total revenue. We have to find the maximum, the quantity that maximizes the total revenue. So here is the maximum quantity. Normally I call it Q max. So here I normally call it total revenue max. So to find the maximum total revenue, first we have to find the quantity and that maximize the total revenue. And to do that is very simple. All what you need to do is the quantity, the level of quantity where total revenue is 0, you just find the average of it. So first of all, if we want to find here, what we have here, these quantities, you just average the quantity, that makes the total revenue. So here, take this, bring this. So this quantity max, to find it, it will be, you add this, that is Q1 plus Q2 divided by 2, that's the average. In other words, we are finding the average of the quantities that leads to total revenue 0. So we have 0, this 0 is this one, then plus this one, the 50. What we are finding, we are finding the average of this distance from here to here. So what you do, add this and divide it by 2, then you will have 25. You'll have 25. So here will be 25. So this is the level of quantity. 25 is the level of quantity that maximizes the total revenue. So then we know the maximum, the quantity that maximizes the total revenue. So if we want to find here, still with question D, what is the maximum value of total, total revenue? So in fact, we can even have another question. We said that even E should come, even this should come here first, but still you can ask what is the quantity that maximize total revenue. So this should even come here, then we have this, but still the same. So now we have 25. So 25 is the quantity that maximizes the total revenue. So at 25, you ask yourself, what is the total revenue? So what you need to do, you plug this into the total revenue to find the maximum total revenue. So with D, is very simple. First, you have to find it, the quantity that maximize the total revenue. And to do that, what we calculate the Q1 plus the Q2 all over 2. So we have 0 plus 50. Then here we have 25. So this is the quantity that maximizes the total revenue. So to find the maximum total revenue, so we will have to substitute this into the total revenue function. And if we do that, it will be minus 2, 25 raised to the power of 2. Okay. 4 minutes, okay. Plus 100, then times 25. So at the end of the day, what we will have, this times this, it will be minus 2. I will take all steps. This we could have plus 2,500. So at the end of the day, this we will have, this times this will be minus 1,250 plus 2,500. So our maximum total revenue, or total revenue max, will be what? 1,250. So you go back to your graph and write that here, 1,250. So when you come to total revenue so far, this is what we need to know. So we see that we have answered this, but I want to make more elaboration, looking at total revenue. Yes.
Can you go back to the D part? You were fast.
Okay. What you didn't understand here?
No, I mean, I was listening. So it.
No, what they ask us, you understand, in to even visualize it. I like the visualization. The D part, first let's understand the question. It's 50% of the mark, whatever. So the D part is asking us what is the maximum value of total revenue. So here, this is the maximum value of total revenue here. They want us to find this, not so. So how do we find this? To find this, you need to find the quantity that maximizes the total revenue. So the question is asking us to find the maximum total revenue. And to find, let's get that first. So to get the maximum total revenue, we need to calculate the quantity that maximizes the total revenue. In other words, we want to find the quantity that will help us to achieve total revenue. And to find that quantity, what you need to do is Q1 plus Q2. Where are these Q1 and Q2 coming from? It's here, we calculated them. So in the graph, is these 2 points where total revenue is 0. You add this and you average it. In another word, 0 plus 50 divided by 2. So once you do that, then you will have this point here, because this is the point whereby the total revenue is the quantity whereby the total revenue is at maximum. So we have this 25, and I guess everyone understand how we got that 25. It's this Q1 plus Q2, then we have this 25. So once you have this 25, then you substitute it into the total revenue. And we know that our total revenue function is what? Minus 2Q square plus 100. So this 25 here, you substitute it here. Wherever you see Q, you substitute it with 25. So once we do that, then we will have this, and this is our total revenue. Is the maximum total revenue. I hope that is clear.
Yes.
Okay. So now we solve this. We understand our total revenue function. These are the typical questions one comes across when you are dealing with total revenue function. Obviously, there might be some twist and here and there, but if you understand this, you should be able to do any twist that comes along your way. So